Hello everyone, welcome to the fifth session on oil hydraulics and pneumatics. In this specific video, we will be covering the fluid power symbols. The content of these videos are need of the fluid power symbols. Then I will be covering the two set of symbols. Very first, the transmission line symbols. Second are the storage device symbols. Now there are various sets of symbols available that we are going to cover in the upcoming videos. But the generalized understanding of all those symbols will be given at the end of this specific video. So let us start with the very first topic, the need of the fluid power symbols. In the previous video, I explained you the fluid power systems. Now those kind of systems can be easily converted into a graphical representation by using the ISO standardized symbols. We are actually using the ISO standard symbols to convert any fluid power system into a fluid power symbolic representation, which is also known as the fluid power circuit. Now, by doing that, it will actually help us, or say it basically helpful to provide a system of the fluid power graphical symbols for the industrial as well as the educational purpose. By converting that fluid power system into a circuit, actually we are simplifying the designing, fabrication, analyzing and servicing process. Now, if we convert any kind of system into a graphical representation, or which is known as the fluid power circuits, we are actually helping everyone to understand our thoughts on that specific system. Okay, so if I have generated any kind of fluid power system, I can easily convert that specific fluid power system into a circuit, and that circuit can be understood by each and everyone who knows those ISO symbols. So it can be easily internationally recognized. And lastly, it will actually promote the universal understanding of the fluid power system. So that's why we need actually the fluid power symbols. Now let me just give you one very basic example of the fluid power circuit. Now this is one circuit which will be helping to move this specific rod in a linear way. Okay, as you can understand, this specific one is a reservoir symbol which is universally accepted. Second, I am having a pump. Thirdly, I am having various kind of control valve symbols which are available over here in the section number 2. And lastly, I am having the utilizing section which will be having the piston cylinder mechanism, or you can say the actuator mechanism. Now all these drawings are actually the ISO symbols. So by using those ISO symbols, I can actually convert any kind of fluid power system into a fluid power circuit. So basically this one is known as the fluid power circuit. Fluid power circuit. Okay. Now before drawing this kind of circuit, you need to actually understand how to draw those symbols and what are the symbols that actually can be used. Okay, so let us start with the very first set of the symbols, which is known as the power transmission line symbols. Now the power transmission line symbols are basically various kind of lines. Very first line, if you can observe, is the continuous thick line, or you can say continuous line simply. Now where is this line available? As you can observe in this specific circuit, there is a line which is going from here in the upward direction, which is actually getting connected in a various kind of valves. Now this specific line is actually representing the power transmission of the fluid. Okay, so the power will be coming from here and it is getting transmitted to various kind of valves. So this line is known as the supply line. To draw this kind of supply lines, we actually use this continuous line. As you can observe, there are a number of continuous lines available which are actually the supply lines. Secondly, after utilizing the power of that fluid, there will be one line which will be returning to the basic reservoir once again. This is known as the return lines. To draw the return lines, we are using those continuous lines. Thirdly, the component enclosure. As you can observe, if this is a component available, I am enclosing this component with this specific line. Thirdly, as a symbol enclosure, if this is a symbol, I am enclosing that specific symbol using the continuous line. So for all these purposes, we are using the continuous line. Second line is actually the dashed line. Now, if you observe, the dashed line is available over here. Now, what is the purpose of this dashed line? This dashed line is actually used as a control line. So what will happen over here? It will actually take some fluid from the main line and it will deliver to the controlling element. Now this controlling element will operate through this specific pilot line. So basically the main task for this specific pilot line is to actually transfer some fluid for the controlling purpose only. It is not the actual supply line, it is just a pilot line. Clear? Secondly, it will be helpful as a drain line. Drain line is what? Once the utilization is done, many times actually we need to transfer the fluid to the reservoir directly. Now that fluid will be directly transferred to the reservoir or it will be left somewhere. In that specific case, we will show that specific path with the help of this line. Now instead of this line, we can use this line also. This is also a dashed line. So we can use them interchangeably. Then after, as a flushing line once again the similar, the drain line, and lastly the bleed line. It will also same to the flush line or say drain line. The third line that we are using is this line, which is known as the continuous chain line. Now this line is used as a framing line. Now what do you mean by framing line? As you can observe, this specific continuous chain line is available over here. This is a rectangular block. Second, this is one more rectangular block which is actually using this continuous chain line. Now as you can observe, this rectangular block is actually containing the various kind of symbolic representations. So these are the multiple components which are covered under this specific line. So basically this specific set of rectangle block represents that these multiple components are available under the single set. Okay, so basically there will be actually a single blocks available in which all these components are available. Clear? So this is why the framing lines are used. Framing lines are actually used to frame those components which are available as a single set of component in actual. Clear? This is also one more example. So this is the use of the line. Now further, to actually check out which is actually using the pneumatic power and which is using the hydraulic power, we can actually separate them with the help of these arrows. If there is a hollow arrow available like this, there is nothing inside the arrow, this will represent that whatever the component available is actually using the pneumatic system. That means the air is the basic component for that system. Like over here, as you can observe, this is one component available, there is an arrow available, and this is the hollow arrow. That means this specific component is actually related to the pneumatic line. That means air is basically used as a power transmitting element. Clear? So this basically a symbol of the compressor. This is the symbol of compressor. Now similar symbol is available over here, but over here the arrow is actually completely blocked like this. Now whenever there is a blocked arrow, it actually represents the hydraulic line. That means the hydraulic or say oil or water will be there, most probably oil will be there. So this specific component is the pump, because to transfer the liquid or say to pressurize the liquid we use pump, and to pressurize the air we use compressor. So this is the symbol of pump, this is the symbol of compressor, this is also a kind of pump. So from these arrows you will be able to understand whether this line is the pneumatic line or say whether the component is a pneumatic component or the hydraulic component. The second are the connection lines. So if there is a pipeline junction, in that case to represent that junction, as you can observe there is a junction available, we use normally dots over here. As you can observe there is a dot available in between. Secondly, as you can observe over here, this is the T junction, over here we have used the dot. Even there is no dot available at the T junction, it is considered as a junction. But if there is a crossing available and there is no dot available, always remember that these are two separate lines. This is the first line, this is the second line. There is no connection between these two lines. This can be further furnished like this also. This is also representing there is a crossing, but there is no connection between these two pipes. This is a separate connection and this is a separate connection. Okay, let me just explain you with the help of this specific diagram. As you can observe, over here there is a this similar kind of crossing is used. So you can say that this line is a separate line and this line is a separate line. There is no connection between these two lines. So you have to remember this thing. Over here, this is a T junction. That means whatever the fluid that is coming from here is also going in this specific direction. So there is a connection over here. Mindset clear? So this is how this kind of things works. Let us go further. Whenever you are having the pipe between 2 points, if the connection is shown in a straight manner, it represents the rigid connection. That means there are rigid pipes available between these two connections. And if it is a flexible connection, there will be some kind of hose used, flexible piping used between these 2 points. Let me just give you one very basic example. Over here, if you can observe, these specific lines are actually the rigid lines. So this can be represented by the straight line like this. And as you can observe, from this rigid end, there are actually hoses available which are actually connecting this first point and this second point. So this specific hose is known as the flexible connection. So we'll be using this flexible line, or you can say simple, what we can say, the curvature line as a flexible connection. So this is how we can give the connection between two sections. Now let me just give you some of the miscellaneous connections, or say miscellaneous symbols. Very first symbol is the pressure line with the cap, or you can say plug. So whether there is an ending or you have closed that specific pipe, in that case you have to show this specific symbol at the end of this continuous line. Second, this is the symbol of the adjustable or variable component. So wherever you see a straight arrow at the 45 degree, that specific arrow will represent the variable component. Like this is the symbol of pump, as we understood in the previous slides. This is the symbol of the pump. Now on this symbol, I am having a 45 degree straight arrow. That says that this pump is actually the variable flow pump. Okay, so this is also known as the variable displacement pump. If this arrow is not available, that pump will be known as the fixed displacement pump. Clear? So this arrow is actually representing the variable component or adjustable component. Okay. Now, next, the thing that is available over here, as I explained you, this is actually representing the reservoir. So this specific set available over here is actually representing the reservoir with the return line. As you can observe, there is a straight line available over here, and if there is a dotted line available, this actually representing the reservoir with the drain line. Clear? So these are the various symbols or connections available. Now let us check out the next set of symbols, which is actually the storage symbols. Now in the storage symbol, we are having the 4 various symbols. Very first is the vented reserve oil, or you can say the vented reservoir. Now over here, this is a non-pressurized reservoir which is actually storing all the oils which is available. Second is known as the pressurized reserve oil. Now reserve oil is basically nothing, it is the short form of the reserve oil, or say reserve oil reservoir. Okay. Now this specific is the rectangle symbol. So rectangle symbol basically represents the pressurized oil reservoir. Third one is the tank with the piping, oil level indicator and the air bleeding. Now this is a reservoir symbol. This is the return line. This specific symbol represents the oil level indicator. So this is the fluid level indicator, and this specific symbol is the air bleeding symbol. Okay, so there are total 4 combination of symbols. Very first is the reservoir symbol, second is the return line symbol, third is the level indicator symbol, and fourth one is the air bleeding symbol. Combinedly it is known as the tank with the piping, oil level indicator, and the air bleeding. Okay, and the last symbol that you can observe is the air tank or reserve oil. So many times this kind of symbols are available. This is the continuous line. Now with that continuous line there is a rectangular section available with the smooth edges, and there is a symbol of the pressure indicator. This is the symbol of the pressure indicator. Now this specific symbol is actually the symbol of the air tank. If there is a compressor available, after that there will be an air tank which will actually keep the compressed air inside. Or this symbol can also be used as a reservoir for the oil, which will be the pressurized oil reservoir over here. This is available over here. So alternatively it can be used as a oil reservoir also. Clear? So these are the various symbol of the storage tanks. Now at the end, let us check out the generalized meaning of the symbols that we are going to understand in the upcoming videos. Very first set of symbols will be the circles. Now whenever you see the circles, you should understand that these circles are actually representing the energy conversion units. Now what is the energy conversion unit? Energy conversion unit are basically converting any energy into another kind of energy. Like we are having the pump. Pump will convert the mechanical energy into the fluid pressure energy. Clear? Like we are having the compressor, it will do the same thing for what? For the air. And like we are having the motor, which will convert the fluid power energy. If it is the hydraulic motor, it will convert fluid power energy into the mechanical energy. So any circle will actually be the energy conversion unit. This is the symbol of the pump, as you can observe. This is the symbol of the pump. This is the inlet line. This arrow represents the hydraulic fluid, and this is your outlet line, and the double line shows that this is a shaft connection, or say there is some mechanical connection available here. Okay, the second is the compressor. As you can observe, this is a triangle available. So this represents the pneumatic series, and pneumatic series pump is not available, there is a compressor available. Okay, so this basically represents the compressor. The second set of symbol is the smaller size symbols. Now the smaller circles are actually showing the measuring instrument. We actually understood in the last slide, these are the measuring instrument. This is the oil level indicator, this is a air bleeding system, this is not a circle. Then this is the pressure gauge. So these all are the symbols which are actually available inside a small circle. So the smaller circle will actually represent the measuring instrument. And lastly, the semi circle will actually helpful to indicate the rotary actuators or semi rotary actuators. So whenever you see the semi circle like this will be an actuator which will actually convert the fluid pressure into the rotational energy. Okay, and this is a semi rotary actuator actually. Okay, so it will be converting the limited angular motion. It will be creating a limited angular motion. The second set of symbol are the squares or rectangles. Now whenever you see such kind of squares or set of squares, you should understand that they are some kind of control valves, except there is only one exception, which is a non-returning valve, or you can say check valve. Okay, non-returning valve is also known as the check valve. So whenever you see such kind of squares, you should understand that they will be representing some kind of control valve. As you can observe, this is one example. This is the pressure relief valve. This is taking one square. This is a pressure relief valve. Second example is the direction control valve. This is the 4x3 direction control valve, which is actually using the 3 squares within it. So this kind of control valves are represented with the help of numbers of squares. The third set of symbols that we will be understanding are the diamond symbols. Now, whenever you see this diamond symbols or say 45-degree rotated square, in that case you should understand that this will be some kind of conditioning apparatus. Conditioning means what? The conditioner is something that will actually filter or say that will actually clean your fluid. Okay, so if there is a filter available, there is any kind of separator available, there is any kind of lubricator available, heat exchangers available, in that specific case you will be able to see this kind of diamond symbol. Like we are having the filter, this is the symbol of the filter which will represented by the diamond. This is the heat exchanger device, basically this is the heater, okay, which will be represented by the diamond symbol. The heater will be indicating this kind of arrows. If there is a cooler, arrows will be reversed. So these diamonds will represent the conditioning apparatus. Square will represent the control valves, pressure control valves or direction control valves or flow control valves. And further, the circles will represent, if there is a bigger circle, it will represent the energy conversion element. If it is a smaller circle, it will represent the measuring instrument. And if it is a semicircle, in that case, it will represent the semi-rotary actuator which will have the limited angular motion. So this is the end of this specific video. Keep learning. Have a good day.